So another general term that is used to describe the different parts of a bridge are what we call appurtenances and site-related features. So what are these? What are appurtenances? Appurtenance is any part of the bridge or bridge site that is not a major structural component yet serves some purpose in the overall functionality of the structure, such as guardrail. So this appurtenances or appurtenance is actually those part of a bridge that actually don't have a major role on supporting the whole bridge structure, but still they serve some purpose in the overall functionality of the structure, such as a guardrail. So in other words, appurtenances are just like an accessory to the bridge. So these are just the major appurtenances and site-related features that can be found in every bridge. The slope that tapers from the abutment to the underpass or embankment is covered with a material called slope protection, which should both be aesthetically pleasing and provide for proper drainage and erosion control. For waterway crossings, large stones, also called riprap, are usually used for slope protection and foundation score protection. So slope protection looks something like this. So slope protection is being provided to prevent erosion of soil, or in other words, it is provided to for erosion control. So this is what we call the slope protection. So when sometimes the slope protection that is being used for waterway crossing is usually made up of large stones, and when that slope protection is made up of large stones, it is usually called a riprap. So this riprap is a slope protection that is usually used on waterway crossings. So that is one of the appurtenances or site-related feature that can be found in a bridge. Another appurtenance another appurtenance or site-related feature that can be found in a bridge is an underdrain. In order to provide for proper drainage of a major substructure element such as an abutment, it is often necessary to install an underdrain, which is a drainage system made of perforated pipe or other suitable conduit that transports runoff away from the structure and into appropriate drainage channels, either natural or human-made. So under drains look something like this. So the purpose of putting an under drain on every substructure of our bridge is to prevent the storage of water behind the substructure. So that's one purpose of putting an under drain on the substructure of our bridge, to prevent the storage of water behind the substructure. So why is that? What will happen if we will have a water that will be being stored behind our substructure? So the tendency will be that stored water will exert an additional pressure to our substructure that can eventually result to failure of our substructure if our substructure is not properly designed to resist an additional load coming from the water pressure that will be exerted on it if there will be a water that will be stored behind our substructure. So in order to prevent the storage of water behind our substructure, we usually put under drains like this, composed of perforated pipes or drain holes, so that water will not be stored behind our substructure. So what will happen if we will provide under drain or under drains is the water will be diverted using those under drains away from our substructure so that this water will not be stagnant behind our substructure and eventually and consequently will prevent it from putting additional pressure on our substructure. So these perforated pipes composed of a pipe that has a series of holes along its length. These perforated pipes will collect this stored water and eventually divert it away from our substructure. So it will divert the water away from our substructure to drainage channels, either natural drainage channels or human-made channels. So natural drainage channels are those like rivers or any body of water, or even directly to the sea. So that perforated pipe can divert the water behind our substructure away from our substructure directly to the directly out of the sea or any body of water. So other type of under drain that is usually used in a substructure are drain holes. So it serves the same purpose as the perforated pipe. So in order for the water to be not stagnant behind our substructure, we usually put a drain hole through our substructure so that water will seep out of that drain hole, and as a result, there will be no water pressure that will be developed behind our substructure, and eventually will prevent uh, substructure collapse or failure, since there will be no water pressure that will be developed behind our substructure. So those are under drain. That is again another appurtenance or site-related feature that can be found on any bridge. The section of overpass roadway that leads up to and away from the bridge abutment is called the approach or approach roadway. To compensate for potential differential settlement at the approaches, a reinforced concrete slab or approach slab is sometimes used for a given distance back from the abutment. The approach slab helps to evenly distribute traffic loads on the soil behind the abutment to eliminate the horizontal live load soil surcharge against the abutment and to minimize differential settlement between the abutment and the approach roadway. An approach slab is typically supported by the abutment at one end and supported by the soil along its length. So this is again another appurtenance or site-related feature that can be found in a bridge. This is what we call the approach slab. So this this short slab that you are seeing here is what we call approach slab, and this part here is what we call the abutment, and this part here is what we call the approach roadway. So as you can see on the figure or on the GIF, the approach slab is that slab that connects the abutment to the approach roadway. So one reason or one purpose of this approach slab is to evenly distribute traffic loads on the soil behind the abutment. So that's one part of purpose of the slab, to evenly distribute these loads, the traffic loads, the vehicle loads that is being supported by the approach slab evenly beneath the soil. So it distributes the traffic loads evenly on the supporting soil behind the abutment. So that's one purpose of the approach slab. Another purpose of the approach slab is to minimize differential settlement between the abutment and the approach roadway, because as the traffic uh, travels along the approach roadway to the bridge, sometimes there will be a settlement that will happen on the abutment as well as on the roadway. So in order to prevent differential or different amount of settlement between the abutment and the approach roadway, we usually put approach slab, so that again to minimize the the settlement, the differential settlement between the abutment and the approach roadway. So as you can see on the figure or on the GIF, approach slab is usually supported by the abutment on its one end, and it is supported by the supporting soil along its length. So you can That is evident on this particular figure that you are seeing here. So that approach slab is usually located on both ends of a bridge as the bridge connects the uh, as the bridge is being connected to the approach roadway. We usually provide the approach slab several uh, distance away from the abutment to connect the bridge itself to the approach roadway. So that is that is an approach slab. That is what an approach slab looks like. So that is again another appurtenance or site-related feature that can be found in a bridge. Another appurtenance or site-related feature that can be found in a bridge are bridge barriers. So and traffic barriers. So what are bridge and traffic barriers? Bridge barriers are provided to restrain vehicles from crashing off the side of a bridge, and traffic barriers are protective devices used to shield motorists from obstacles or slope located along either side of a roadway. So what do bridge barriers look like? So this is a bridge barrier. So you can see bridge barrier on either side of a bridge with the purpose of preventing the vehicles from crashing off away from the bridge itself. So that is the bridge barrier, the feature that you are seeing on the side of every bridge. And the traffic barrier is look something like this. This is an example of a traffic barrier. Traffic barrier serves different purposes. Sometimes traffic barrier are used to divide the bridge or the road into several lanes. Sometimes it is used to prevent vehicles or the traffic from crossing one lane to the other. And sometimes traffic barrier is used to shield motorists from obstacles or slope located along either side of a roadway. Say for example, if there is a construction uh, or I mean if there is a construction activity happening on one side of the roadway, sometimes we use traffic barrier so that the traffic or the vehicles that are using the bridge will be prevented from crashing of that construction site on the particular bridge that we are concerned. So those are the bridge barrier and traffic barrier. Those are the appurtenances and site-related features that can be found in a bridge. So these appurtenances and site-related features are not actually part of the structural component of the bridge. They usually don't play a vital role on supporting the whole bridge, but still they serve some purpose in the overall functionality of the structure or the bridge structure.